A healing forest, secondary succession at Point Pleasant Park following Hurricane Juan in 2003.
Point Pleasant Park has served as an iconic aspect of Halifax since the 1960s. It first served as a British defensive site, eventually shifting into a recreational area with expansive trail systems and beaches. Throughout history, Point Pleasant Park has also held deep significance within the Mi'kmaq Nation, serving as a gathering place for significant annual spiritual ceremonies, connecting with the natural world, as well as the 2023 location for the North American Indigenous Games. In late September 2003, Hurricane Juan, a Category 2 hurricane, made landfall in Halifax and wreaked havoc on the park, uprooting thousands of trees and ultimately destroying 70% of the forest canopy. Prior to Juan, Point Pleasant Park was a diverse mixed Acadian forest ecosystem dominated by species of red spruce and white pine. After the hurricane, the damage to the park was so severe that it remained closed for 8 months. Secondary succession can be defined as a major and catastrophic ecological event that destroys the ecological community within the area without disrupting the soil in the disturbed area. Since Juan, the forest ecosystem has been altered irreversibly. This project aims to identify and investigate specific trends in the secondary succession of the park's ecosystem, allowing us to make educated predictions on the changing forest ecosystem as it progresses from an early successional forest to a late successional forest ecosystem. The primary objective of this study is to assess, document, and investigate the impacts of Hurricane Juan on the biodiversity and regeneration of Point Pleasant Park Forest's ecosystem after Juan's destruction of the prior climax community. Our null hypothesis for this study is that there will be no statistically significant relationship between total tree density, dominant species density, species richness, and the time following the hurricane in Point Pleasant Park Forest ecosystem. Our alternative hypothesis examines the potential for significant changes in the forest ecosystem and explores the possibility of a statistically significant increase in total tree density, dominant species density, and species richness and over the time following Juan in the Point Pleasant Park ecosystem.
6 study sites were chosen to be assessed based on where in Point Pleasant Park had suffered the most severe hurricane impact on forest structures. These sites were 20 meters by 20 meters in dimension, and all data was collected by Dalhousie University students enrolled in Biology 2060 under the supervision of a lab instructor. In each study site, all living trees greater than or equal to 2.5 centimeters in diameter at breast height, defined as 4.5 meters from the ground, were identified using a field guide and measured in data collection. Data was collected annually from 2004 to 2023, except for 2005, 2007, 2016, and 2020, all due to hurricane events, and in 2020, the COVID-19 pandemic. In this graphic, we can see the 6 study sites used for data collection. Our variables of interest for this experiment were total tree density, dominant species density, and species richness per 400 meters squared. We examined relationships between each of these variables in respect to time following Juan and used a regression analysis for all variables to test for significant statistical relationships between each of the examined variables in relation to time. The aim of this aspect of the study was to determine if there is a statistically significant relationship between the total tree density per 400 meters squared and time in years following Hurricane Juan in the Point Pleasant Park forest ecosystem. To determine the strength of the relationship between variables, a regression analysis was carried out on the total density data over the period of 2004 to 2023. The regression analysis indicated an increasing and moderately strong significant relationship with an R-squared value of 0.54 and a p-value of 3.1 times 10 to the negative 15 between the two variables. Therefore, we reject our null hypothesis in favor of our alternative hypothesis. A similar study completed by Bassnet in 1997 on a tropical forest ecosystem confirmed that the recovery rate of trees following a more severe Category 5 hurricane in the area had also increased significantly following the hurricane. The presented results, both from the collected data as well as the study completed by Bassnet in 1997, are enforced by successional theory, which states there will be an increase in diversity and richness of a species following a major ecological disturbance. This correlates with the overall observed increase in tree density over time in the Point Pleasant Park forest ecosystem. Due to the extremely long-term nature of succession in forest ecosystems, we will not see the late successional climax community emerge in our lifetimes. The present-day growth at the study sites in Point Pleasant Park are in the early successional stages of a forest ecosystem. As the dominant trees continue to grow, they will establish canopy dominance, and eventually competition will result in a decrease in density among the dominant species, and canopy space will become available under the towering canopy. This tree mortality will allow for light to enter the vacant canopy space and allow new trees to grow, creating a varied forest climax community.
We investigated the relationship between the measured densities of red spruce and red maple trees at Point Pleasant Park in years post-hurricane. Since 2004, the dominant tree species at Point Pleasant has shifted from red spruce to red maple. Both species have increased in density from 2004 to 2023 across the study sites. After Hurricane Juan struck in 2003, the dominant tree species in 2004, red spruce, experienced a 55% increase in average density across the sites at Point Pleasant, with an average density of 7 trees per 400 meters squared in 2023. In comparison, the species that is currently dominant, red maple, had a density of 0 across all study sites prior to 2004, but had increased to an average density of 36 trees per 400 meters squared in 2023. Thus, we reject the null hypothesis that there is no significant relationship between the densities of red maple and red spruce trees and time post-hurricane. The slopes of the linear regression analyses performed indicate that the density of red maple trees is increasing at a faster rate than the density of red spruce trees. However, the R-squared values for these regression models are low, as the rate of increase in tree density differed at each of the study sites, contributing to a large spread in the data. Overall, both tree species are increasing in density at Point Pleasant Park following the effects of Hurricane Juan. It is important to note that red maples are an early successional species, while red spruces are a late successional species. Thus, the presence of red spruce at Point Pleasant Park indicates that it was likely a late successional forest prior to the impact of Hurricane Juan. However, as red maples are now the dominant species, this indicates that the forest at Point Pleasant has likely become an early successional forest after undergoing extensive damage due to the hurricane. This transition to an early successional forest is not ideal, as late successional forests are not as abundant and thus contain biodiversity that requires greater conservation efforts. However, red maple trees have been shown to promote late successional growth of forest ecosystems when they are fully mature, and thus, their growth may eventually result in Point Pleasant Park transitioning into a late successional forest once more. While the large spread in the data makes it difficult to predict the rate at which the density of the species will change over time, the densities of red maples and red spruces are both likely to continue to increase over the near future. However, if the conditions of the early successional forest continue to be favorable for forest maturation, it is possible that red maple density growth will begin to plateau and red spruce density will increase at a faster rate as the forest transitions into a late successional ecosystem and reaches its climax community.
Our null hypothesis here is that there is no significant relationship between species richness and the time after Hurricane Juan in the Point Pleasant Park forest ecosystem. The study aims to establish the existence of a significant correlation between species richness and the passage of time in the park. Annual data on species richness was collected from the park in Halifax, Nova Scotia, via 6 replicated sites by Bio 2060 students. To evaluate the strength of this relationship, a regression analysis was conducted on species richness with data spanning from 2004 to 2023. The regression analysis revealed a noteworthy positive correlation with an R-squared of 0.64 between species richness and the years following the hurricane. Hence, species richness in the park could be estimated based on the duration since the occurrence of Hurricane Juan, utilizing the regression equation where species richness equals 0.59y minus 1181. These findings support a significant relationship between species richness and the years following the hurricane. So we can reject our null hypothesis, which suggested that there was no relationship between species richness and time after the hurricane. We can infer that the hurricane likely had strong influence on species richness. This augmentation in species richness post-catastrophic event aligns with Turchin's theories, suggesting that increased disturbance resulting from the hurricane led to increased species richness, accumulating in a more diverse future climax population by opening the ecosystem to disturbance. Based on the findings of Fisher and her team regarding the effects of flooding disturbances on plant communities, we can predict that the species richness of Point Pleasant Park will likely continue to increase over the time following the hurricane. Fisher's study suggests that disturbances, like the flooding and like the hurricane, can lead to heightened species richness, particularly in communities with diverse ecosystems like Point Pleasant Park, with all of its disturbances from the sea and from the hurricane and from the immense tourism that passes through every day. In the graph shown, we can see how most changes made to a stable ecosystem ultimately result in a reversion to the status quo, where the loss of species richness can be countered given time to regrow. In the case of Point Pleasant Park, it's even possible for more richness of species following the disaster. Applying this insight to the aftermath of Hurricane Juan, which caused significant disturbance in the forest, it is reasonable to anticipate a similar pattern of increasing species richness. The high level of disturbance caused by the hurricane likely created favorable conditions for various tree species to establish and thrive, contributing to the greater diversity of the forest as the forest reaches its inevitable climax community.
Overall, the forest ecosystem at Point Pleasant Park appears to be recovering from the destruction caused by Hurricane Juan, as the density of trees and richness of tree species is steadily increasing. However, based on the dominant tree species present, it is likely that the Acadian forest at Point Pleasant Park is in an early stage of secondary succession, and future studies should further investigate how this is affecting local ecosystem dynamics. For example, the structural strength of trees in early successional forests tends to be lower than in late successional forests, potentially indicating that the forest at Point Pleasant Park may be at an increased risk of damage from hurricanes in the future. As an urban park, the delicate dynamics of secondary succession can also be hindered by human interference at Point Pleasant. For example, the trampling of sprouting trees, weeding of saplings, and mowing of grassy fields can reduce the increase in richness and density associated with ongoing forest regrowth, and these factors should be minimized as much as possible. As the Mi'kmaq Nation has been connected to Point Pleasant Park for generations, scientists who study secondary succession at Point Pleasant should continue to incorporate the traditional knowledge into their work through two-eyed seeing. This will allow important decisions to be made with the well-being of the land and its inhabitants in mind. A logical question to now ask ourselves is whether the results of our study can help inform conservation efforts at Point Pleasant Park and how we can incorporate Indigenous practices and perspectives into these efforts. Acadian forests, such as Point Pleasant Park, are characterized by productive soils and high tree richness, making them resilient ecosystems that can effectively regrow and mature without additional interference. According to historical records, while the Mi'kmaq relied on the Acadian forest for food and shelter, they did not wish to physically alter the forest and did not actively engage in the clearing of trees. This practice of leaving the forest community undisturbed allowed the Acadian forest to successfully grow and mature over generations. Our results indicated that Point Pleasant Park is successfully regenerating as an early successional forest, increasing in both tree diversity and density. We can learn from the traditional practices of the Mi'kmaq and allow the forest to heal from the devastation caused by Hurricane Juan without interfering. This process could include mandating that citizens enjoying the park remain on pre-existing paths so that seedlings are not trampled underfoot, and refraining from forming new paths or monuments, as this reduces the available habitat for tree growth.
A typical Acadian forest is already particularly vulnerable to adverse weather events such as windstorms, wildfires, and insect infestations as a result of human impacts on Acadian forest dynamics. In Nova Scotia specifically, it has been predicted that climate change will cause a higher number of severe storms annually, and this could have a negative impact on the already vulnerable secondary succession forest population in Point Pleasant as it continues to establish itself. Elevated atmospheric CO2 levels, a staple of climate change and global warming, have been shown to limit available nutrients in forest ecosystems. The implications of decreased available nutrients have been linked to a decrease in photosynthetic productivity in forest ecosystems. Therefore, it can be concluded that global warming, and specifically the impact of increased levels of CO2 in the atmosphere, will not only decrease overall biological production in Point Pleasant Park, but slow the growth of tree species and overall create a more vulnerable forest ecosystem.
Point Pleasant Park is an Acadian mixed forest, featuring trees like spruce, mountain ash, maple, and birch. This diverse ecological makeup played a role in the park's response to Hurricane Juan. The storm's high winds led to considerable damage, as touched on in previous slides. For carnivorous trees, their shallow root systems were particularly susceptible to uprooting or snapping, despite the resilience of the deciduous species with deeper roots, they still suffered damage with the high winds snapping branches and the smaller ones being uprooted. Salt spray, a result of the storm's winds whipping up ocean water, had effects on species not adapted to high salinity environments. When salt spray settles on leaves and needles, it can interfere with their ability to perform essential functions like photosynthesis. The salt can dehydrate plant tissues and disrupt nutrient uptake. Prolonged exposure to the salt spray weakens plants, making them more susceptible to environmental stresses. After much maintenance and given time, the park will soon be healthy and at climax community again.
We would like to acknowledge that this study was conducted at Amantukatsi, or Point Pleasant Park, Nova Scotia, on the unceded and treaty territory of the Mi'kmaq. When surveying the environment, it is important to remember its historical inhabitants and to respect their interactions with the land. We are all treaty people. We would also like to thank Dr. Alison Schmidt and all of her students for collecting this data over a span of 19 years. By having an extensive dataset such as this, we can effectively examine changes in the dynamics of the forest at Point Pleasant Park over time. Thank you.